So force in motion. Like I said, we were talking about this yesterday. We watched the video about it yesterday. Force. When we say force, when we're talking about science, we're not talking about that thing from Star Wars. We're talking about a push or a pull that can make an object move, stop, or change direction. Okay? Like I told you yesterday, when we're talking about forces, we can split them into two big groups. Number one, a push, or number two, a pull. Two main groups that we can split forces into, either a push or a pull. What a force does is when you apply that force to an object, it makes it move. Or if it's already moving, it can make it stop, or it can make it change the direction that it's moving. We have here in this picture an example of a ball here. Someone applied a force to it, and we can see that the ball starts to roll to the right. When we watched that video yesterday, they told us about some of the laws of motion. One of those talked about inertia. What that means is an object is at rest. If it's not moving, then it's not going to move on its own. If you have, like here, if I put my phone on my hand there and I leave it alone, it's not going to start moving on its own. It's going to stay there. If I want it to move, I'm going to need to apply some force, a push or a pull, to change where it is. Once it's already moving, it's going to want to keep on moving, doing what it was doing, until another force makes it stop or makes it change the direction. The next word that we're going to talk about is gravity. In the video, it had told us that gravity is working on all of us. It's affecting all of us all the time. And that's true. Every single second of every day, whether we're awake, whether we're asleep, whether we're eating or running or happy or sad or whatever. Gravity is always working on it. So gravity is a force that tries to pull two objects together. In this case, the two objects, the two things that it's trying to pull together are us and the Earth, the planet. Now, because the Earth is so much bigger than we are, and because it's so much more, it's so heavy, it's much more heavy than we are, it's got so much more mass than we do, we are the ones that go toward it. A good example of this is like, I want you to raise your hand if you've ever been on a trampoline before. You've been on a trampoline, raise your hand. Okay. Those of us who've been on a trampoline, we know that sometimes when you're walking around on a trampoline or you're jumping around on a trampoline, that it can be very tough if someone starts to jump or walk around where you are. You kind of start like going toward them. That's what happens with gravity. The Earth is pulling us toward itself. Now, again, it works all the time, every second of every day, whether we're awake or we're asleep or anything. So you might wonder, well, how come we're not always just laying on the floor? How come I'm able to stand up or I'm able to jump? When we're standing up, when we're walking around, when we're jumping, we're using our muscles to fight against gravity. They showed us in the video yesterday a big heavy anvil made out of metal. And he had tied it up to like a crane, and the crane would pick it up and hold it up in the air. Just because the crane is holding up the anvil doesn't mean that gravity's gone. Gravity was still working on it, and the crane had to fight against gravity to pick it back up. The same way that when we stand up, our muscles have to work against gravity to hold us up. And when you jump, Your muscles have to fight even more against gravity, not just to stand up, but to jump up into the air. That's why sometimes if you guys have ever, well, really ever done anything and you've been really, really tired and you try to stand up afterwards, and it's almost like you almost can't even stand up because you're so tired. Whenever you're just standing around or even walking around, it takes energy. If you've ever gone on a really long hike or a really long walk, you know that walking around takes energy because you're always having to fight against gravity to stay standing up. Magnetism. Magnetism is a pretty fun one. So magnetism can be either a push or it can be a pull. So it's not always a pull, it's sometimes a push. It's between two objects and it acts at a distance. What that means is magnetism doesn't need the two objects to be right next to each other. It doesn't need them to be touching. There can be space in between. I'm pretty sure we've all used magnets for something at some point. We've used magnets on a refrigerator or, somewhere, stuck something on with a magnet. But I want you to raise your hand if you've ever had it happen where you try to put a magnet either next to another magnet or onto something else, and instead of the magnet sticking, it like pushes away from it. Almost like there's an invisible bubble or like an invisible ball between the magnet and whatever it is you're sticking to. So that's what I mean when I say that magnetism can be a push or a pull. A lot of times the magnet is going to pull onto and stick onto whatever it is you're trying to stick the magnet to, whether it's a refrigerator or whatever. Yeah, Chase, it feels like a force field. But sometimes the magnets push away from each other, and that's where you get like that force field type of feeling. I want you to look at this picture. Okay, it shows us some examples of magnets. Notice that it has, I'll zoom in here a bit. Notice that it has these letters here, N and S, N and S. If you've ever heard about, like on Earth, we have the North Pole and the South Pole, that's what those are. The Earth is actually one giant magnet, which is why it has a North Pole and South Pole. Every magnet, no matter how small it is, has a north, a south. The way magnets work is it's kind of like everybody getting in line, okay? When people get in line, they face the same way, right? Everyone's facing toward the front of the line. That's where they're all looking. Magnets work the same way. So when magnets stick together, what you're doing is sticking the north side of one magnet to the south side of another magnet. That way, everything in the magnet is still pointing the same way. Those times where you try to stick it to something and you get that force field, invisible bubble type feeling and they just don't want to stick together, it's because what's happening is you're trying to stick a north side with a north side or a south side with the south side. It doesn't work because in that case, it's like if you were waiting in line, I don't know, let's say you were waiting in line at the movies, okay? And you're waiting to go into the movie theater. Everyone's facing toward the movie theater so they can see when they're able to walk forward and when they're finally able to walk into their movie theater. If you were going to go get in line, would you go into line for the movie theater and then face toward the parking lot? No. That's what's happening if you try to stick a north side with a north side or a south side to a south side. You're not lining them up correctly, which is why they kind of fight against it. It doesn't want to be lined up incorrectly. It wants everything to be facing the same way. So a north side will stick to a south side will stick to a north side, but it doesn't work if it's a north and a north or a south and a south, because then everything's not facing the same way. It's like they're facing opposite directions, and it's going to want to push away. The next one is friction. So friction is a force that slows or that stops motion when objects rub together. So really quickly, for just a little bit, I want you to take your hands, put them like this in front of you, and I want you to just start rubbing them. Move one hand up and then down. Just do that for a little bit. If you can, do it nice and fast. Don't do it slow. A little bit fast. And after a little bit, you're going to start to feel your hands get warmer and warmer. Once you feel them get warm, you can go ahead and stop. So this is a really neat trick on a nice cold day if you walk outside and it's super cold. But it gets nice and warm, and then you could feel them on your face or on your neck, whatever. The reason why your hands get warm is because of friction. When you have two objects right next to each other, and they try to move around, friction tries to stop them, tries to hold them in place. Some things or some objects have more friction, and some objects have less friction. So, for instance, raise your hand if you've ever like walked around your house wearing socks, and then you go into the kitchen and you like slide a little. So when you're wearing socks and you're walking around like on tile floors and things like that, there's not a whole lot of friction. So if you walk really fast and then stop, you can like slide through the kitchen and things like that, because there's not a lot of friction going on. The same thing has happened if any of you have ever gone bowling. And I don't know if you know this, for those of you who haven't, whenever you go bowling, you're not supposed to step into the lane, the part where the ball actually rolls down. You're not supposed to. You should stay out of that. But if you accidentally go a little bit too far, you can step on the lane. And if you do, it's very easy to slip and fall. That lane where the ball rolls is super, super slippery. Very, very slick. It doesn't have a lot of friction. That's because when you roll the bowling ball, you want it to roll and roll and roll all the way down the lane. So it doesn't have a lot of friction. It's not only if you have tile, Alexa, it just depends on the kind of floor that you have. Now, it works a lot better with socks because your feet, your skin, actually has a good amount of grip. And that's by design. Otherwise, if your skin was super slippery, it'd be really hard to hold up water bottles or anything. Everything would just slip out of your hands and things like that. What's your question?
Mine?
Mm-hmm.
Oh, last time I went bowling, I was like 4 or 3 or 2.
Mm-hmm.
And then I threw a little bowling ball with the little slide. And then I thought I was going to play with it. So I went where the slippery stuff is. And I almost fell into that hole wherever the ball knocks down the bowling pits.
Yeah, if you ever walk onto that lane, it is very, very hard to actually walk on it. It's very easy to slip and to fall and to almost feel like you get stuck.
Yeah,
right,
my
Chris,
mom
it's called the
help me.
gutter. Yeah, you gotta kind of like almost crawl out of there. Now, the opposite of that are surfaces that have lots of friction. So take a look at this picture here. We've got a race car on a racetrack. Things like sidewalks and streets have a lot of friction to them. That's by design. There needs to be a lot of friction on those, like the streets and on the race part, on the tires of the car, on streets and on racetracks, because if there isn't, it can end up being very, very dangerous. Especially when it like rains, or in our case, like recently it snowed here. If the tires on the car, or if the roads don't have a lot of friction to them, then cars can slide around the same way that we slide around the kitchen in our socks. And if cars are sliding around, they can crash into each other and people can get hurt. So when they make tires for cars, they make sure that they have lots of friction, lots of grip, traction. That way, even if it's raining that day or if it's snowing that day, your car is not going to slide around the road, that you can control where it's going to go. If you see here, like the race car, some of you guys, if you've ever seen like drag races, when they have races at the drag strip, two cars start at the starting line, And when they go, when the light turns green and they take off, you see tons of smoke coming out of the back of these cars. Not because the cars catch on fire, but because the wheels are turning against the road. And because of all that friction, they heat up and they start to actually burn part of that tire. If you look in the road sometimes and if someone had to like step on their brakes really hard and you look at the road, you can see these black stripes going down the road if you've ever seen them. That's like a real thin layer of burnt rubber from tires. That's from the friction. Yeah, they call it skid mark. The other thing happens with like a ruler, or sorry, not a ruler, an eraser. If you're doing your work or you're drawing a picture and you take an eraser and you erase, you messed up something. If you ever feel the eraser after you've been erasing something, especially if it was a lot, and you feel the end of the eraser, it feels warm because of all that rubbing you did on the paper. And if you look on your paper after you've been erasing, it's got these little like flakes or little pieces of that eraser left on the paper that usually you have to wipe off. Yes, Violet.
My dad taught me how to make skin marks with my bike tires.
Mm-hmm.
To step on my brake, makes my brake stop, and then it makes them.
Exactly. So when you step on your brakes, it doesn't let the tire keep turning, and it rubs or scrapes against the ground, and it leaves that little well, I guess you can call it like a little trail of scraped off rubber. But if you ever feel your bike tires after you do that, the part that was on the ground, they'll be a little bit warm because of all that friction between them and the sidewalk or the road or things like that. Okay, our next word is motion. So motion is just when something moves from one place to another. Moving from one place to another is called motion. In this picture, we have a plane that's flying from one place to another place. Now, this isn't the kind of plane that a bunch of people would buy tickets for and go and get on to go visit their families or anything like that. This is just a plane that's big enough for one person. But even you taking your pencil, lifting it off of your table and holding it in your hand, that's motion. You're changing where the pencil was. When you get up and you walk over to the other side of your room to close the door, that's motion. Whenever something changes where it was, that's motion. A fighter jet would also have motion, very fast motion for a fighter jet. Position is the word that we use to tell where an object was, its location. So like on a map, you looked at a map, in this case a map of Texas. It's got little dots all over Texas, and those little dots are the position of different towns, different cities in Texas. Like El Paso, like San Angelo, Austin, Dallas, Fort Worth, Houston, San Antonio, Corpus Christi. Those little dots show you where in Texas those cities are. Del City. Push. So remember, push is one of the big types of force. A push is when you use force to move something away from you. So that's the way you tell a push and a pull apart. A push makes something move away. Like when, I don't know, when your little brother or sister tries to come into your room, but you don't want them to be in your room right now and you want to be alone. You go, hey, get out. You try to get them to leave your room. That's a push. You're trying to get them away. Or another example would be like if you're going to play soccer and the ball comes rolling towards you, but you want it to go the other way. You want to kick it into the goal. When you kick it, that's a push. You're pushing the ball away from you. So anytime you're moving something away from you, that's a push. Even like right now I'm sitting in my chair, and if I push on my desk, I move the desk away from me. I get further away. That's a push. Now the opposite of that is a pull. A pull is any kind of force that makes two things move closer. So here we've got an example of this guy. He's tied himself to a truck. He's using a rope and he's pulling himself forward on this rope. Another example would be like when you get a piece of pizza and you want that pizza to be in your mouth and in your stomach because it's so delicious. You pull it towards your mouth. You're trying to make it closer. Yeah, this is what they call a strongman competition, Chase. So they do different activities, different competitions to see who's the strongest one. Another example of a pull would be like when you put on your jacket or you put on your clothes in the morning. You pull them on because you're getting them closer to you. Yeah, some of those competitions are pretty impressive. I don't know how they do some of the things that they do. It is very, very impressive, some of the weight that they can pick up. This part is the part where you're going to be doing this on your own. Okay? There are 1, 2, 3, 4, 5, 6 questions. And the way these questions work is this. You've got a sentence here that's underlined. The sentence is not finished. And then under the underlined sentence, there's a blank box. And there's 2 blue rectangles. What's going to happen is I'm going to read the sentence, and then you're going to look at these blue rectangles, and whatever blue rectangle you think would finish that sentence, you're going to put it in the box. So the first one says, when you jump up into the air and fall back towards the ground, it is because of blank. So if you think that you fall down because of magnetism, you're going to grab this box and put it here. If you don't think that, if you go, no, I don't think that's it. If you think gravity is the reason why you fall back down to the ground, you're going to take that box and put it there. So whichever word you think belongs at the end of that sentence, you're going to drag it up into this empty box here. When you jump up into the air and fall back towards the ground, it is because of blank. Either magnetism or gravity. Drag whichever word you think makes sense into that box. Hold on, Jada. Hold on. The second sentence says, a push or a pull that causes something to move or to stop is called a blank. If you think it's called a force, drag that rectangle, put it in the box. If you think it's called a position, move that rectangle into whatever word you think finishes the sentence. When something moves or it changes places, we call that, you think it's called motion, put that in the box. If you think it's called a push, put that into the box. A force that slows or stops things when they rub together is called blank. If you think that's magnetism, put it in the box. If you think it's friction, put that in the box. The next sentence says an object's location is called blank. If you think that's called position, put it in the box. If you think it's called motion, put that in the box. Final question. When you use force to move something away from you, it's called a. You think it's called a pull? Put that in the box. If you think it's called a push, put that in the box. When you finish with them, I want you to look back at them really carefully. Make sure that you put one of the rectangles into the box for every single question, and then you can turn it in. But make sure that you answered all of them first. Okay, so long as you answered every one, Chase, because you don't want to leave any blank, because if they're blank, it's wrong.